In this illustration, we intend to simulate double-stage yielding coupling beam damper under cyclic loading in the Abaqus software. As you observe in this picture, the model includes shear panel, connecting part, bending component, stiffener, end plate, and plate. In this problem, the shear panel is made of Ly160 milled steel. In this problem, a cyclic loading is applied to the top of the model and then its hysteresis diagram will be drawn. In this picture, the hysteresis diagram obtained from the Abaqus software has been compared with the laboratory results. In these pictures, the deformation of the model in the Abaqus software can be observed. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Development of Double-Stage Yielding Coupling Beam Damper. In this picture, the laboratory model can be observed. I will click on Translate Instance, select Bending Component, Done, and move that as much as 288 millimeters to the left side. I will click on Translate Instance, select the plate, Done, and move that as much as 144.5 millimeters to the left side. I will click on Linear Pattern, select the plate, Done, enter offset equal to 525 millimeters, and OK. So here I will enter the number of stiffeners 6. Offset equal to 75 millimeters. Here I will click on Assign Section, select the Web of Shear panel, Done, and OK. Done. Here select Bending Component and OK. I will click on Create Material. Here I intend to define the properties of Q345. After that, I will click on Mechanical menu, select Plasticity and Plastic. Yield stress is equal to 365 megapascal and ultimate stress is equal to 514 megapascal. As you observe, in the picture the thickness of plates is equal to 50 millimeters. OK. Click on Seed Part, enter Approximate Global Size equal to 15 millimeters. OK. Click on Assign Mesh Control, select The whole of the model done. Here select medial axis, OK, click on mesh part and yes. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. The horizontal axis is displacement and vertical axis is force. I will click on Create XY Data, select ODB Field Output, continue, here select Unique Nodal, then select RF2, or the same reaction force directed at Y. After that, I will select U2. Then I will select Set 2 that is related to the place of cyclic loading and click on Save As. In the next step, I'll click on Create XY Data, select Operate on XY Data, continue. Here I will select all reaction forces. Then select Sum option. Click on Add to Expression, then click on Save As. And in this manner, all reaction forces will be added up together. In the next step, I'll click on Combine. First select U2, then Force, and click on Save As. Here, you observe the hysteresis diagram of the model. I will transfer that to the Excel software. The first column is displacement, the unit of which is millimeter. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with green color is the one obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are so close to the laboratory results, which show this problem has been simulated correctly in the Abaqus software. In fact, the results obtained here are similar to those mentioned in the article. Here, you can observe the deformation of the model in the laboratory, and here the deformation of the model in the Abaqus software can be observed as well.